Hello and welcome to another one of Dee's ADD videos. Today we're going to look at some basic examples of logarithmic derivatives. Remember, try to use this basic rule here. The natural log of something, you take the derivative of that something, whatever it is, and then divide by that something untouched without the natural log present. The only difference if there's a log is you have to do the ln of that number below. Use your log rules to simplify. This one will be very helpful. Sometimes you'll use these two as well. And go back over the concept video if you have any questions or want to look at the log rules, algebraic log rules in more detail. Okay, so let's look at these three basic examples. The first one, we have this as our box, so literally it'd be the derivative of the 2x and over the 2x. So the derivative of 2x, you should know by now, is 2 over 2x, which simplifies as 1 over x for your final answer for the derivative. Okay? Let's look at this example here. Here we have a little bit more going on, so I'm going to do algebra to first rewrite it as ln of x squared minus 1. This is going to be to the 2 over 3, 2/3. Now if I did it as is, when I take the D box, the box being this right here, you should be able to notice that this is going to be a chain rule because of these two things there. So what you can do is you can bring that exponent down in front right here of the logarithm using this rule over here that says that if I have an exponent I can bring it down as a coefficient in front there. And when you do so, it eliminates that whole chain rule and makes your life much easier. Because now you have this expression. Still y equals, this is still all algebra, but now this derivative becomes a 2x over the box, right? This is the D box part right here, and this is the box itself. And then we can't forget about our 2/3 that's multiplied in front. So our final answer, oops, sorry about that, should be 4x over 3 times x squared minus 1. You can distribute that 3 if you want to, but it's not mandatory. Alrighty. Now let's look at an log example. And that one would be right here. So the only difference would be we would first rewrite it using our algebraic rule. And it's to the 1/2, bring that down in front as a coefficient. And then just do your D box over box thing. Still y equals, still algebra. Now we can do dy dx equals, and in this case it's going to be 1 over 2, and then we're going to have the ln of 3, right, because it's not ln of e, that's what natural log is. And then times D box over box, so let's just go ahead and do that. Negative 4 over 1 minus 4x, so that becomes negative 4 and 2 can cancel a little bit, right, leaving you a negative 2 up top. So the final answer should be a negative 2 over ln of 3 times 1 minus 4x. Okay? Hopefully that's cleared things up. Now real quick, had you not done that algebraic step, look how much more confusing that D box becomes, just the derivative. You would have had to do this, and then you would have had to multiply by the derivative of the inside, then you would have had to bring that down. Already it's just too many steps. We did this all in one step here. We would have 1 minus 4x down there to the 1/2. Then you would need to combine it with the other part, your D box over box. And people just usually get mixed up in their algebra, so I tell them don't do it this way. Try to always take the easier road, right? if you're asked to go to Mexico from Dallas, you're not going to start heading north. It's going to be quite a journey. You'll probably never make it there. But if you head south, on 35, you'll get there in no time flat. So, practice, practice, practice. Check out some of the more intricate problems for logarithmic differentiation. But the basic rule is just take the derivative of the box over the box and make sure that you use algebra when applicable. Okay? I hope this has clarified things a little bit. Practice, practice, practice. Thank you and have a nice day.